In the last class, we have studied about the magnetic dipole and magnetic dipole moment, how the magnetism is going to origin, as well as we have seen some cases, that is what the important cases of the magnetic dipole moment. If the bar magnet, if I cut horizontally, what happens to the pole strength, as well as if I cut the bar magnet vertically, what happens to the pole strength. All these things we have studied in the last class. So today we shall start the important terms in the magnetism, that is what the concept magnetization intensity. Okay, so this is one of the important term which it is occurring in the magnetism. That is what the magnetization intensity or intensity of magnetization. Anything you can call. In the exam they may ask the intensity of magnetization. The magnetization. Okay, that is what I can say the magnetization intensity, the intensity of the magnetization, or just a magnetization I can call. So, what do you mean by the magnetization intensity? If I consider a external magnetic field lines, this is our external magnetic field lines, is B0, okay? In this external magnetic field lines, if I place a material which is nothing but the magnetic material, that means it has been having the magnetic property. Okay, this is our magnetic material. This is our external magnetic field lines. In these external magnetic field lines, I have placed a magnetic material inside this. What happens to the material now if I place the magnetic field under the external magnetic field? Now, this material is going to produce the magnetic field. Here also, it is applying the magnetic field. So, what do you mean by the magnetization intensity? This is the magnetic field of the material. This is our external magnetic field. This is our magnetic field of a material which I have placed inside a external magnetic field. So here now this has producing the magnetic field due to the external magnetic field. Okay, therefore in this magnetization, what it represents, that means the material, earlier it was not magnetized. Before keeping inside the external magnetic field, it was just a material. When I place this magnetic material inside the external magnetic field, this is going to magnetize. Due to the external magnetic field, now this material has become the magnetized due to the external magnetic field, that I call it as the magnetic field is produced because of this. Okay, so actually these all materials, as I told you in the last class, all the materials are not the magnetic materials, only the unpaired electrons. Wherever the existence of the unpaired electrons, there it is going to occur the magnetic properties. Here in the same way, here the magnetic material which I am taking, okay, this is unpaired electron type particle or a material or a substance or a specimen, I can say. Now it has become the magnetized because of the unpaired electron present in the material. Here the unpaired electron, because of that there is a magnetic dipole exists. Where there is a magnetic moment, there the magnetization is going to occur. So generally it depends upon the nature of the material. On what these magnetization intensity is depending means is depending upon the nature of the material. Okay, and how you define this magnetization intensity? Generally, this magnetization intensity is nothing but the extent to which the material is magnetized. ಅಂದ್ರೆ ಅಪ್ ಟು ಎಲ್ಲಿವರೆಗೂ ಈ ಮಟೀರಿಯಲ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗಿರುತ್ತದೆ ಅದನ್ನ ಮೆಷರ್ ಮಾಡೋದೇ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಇಂಟೆನ್ಸಿಟಿ. More the magnetization intensity, more the magnetization of the material is going to occur. Therefore, this is what the general talk. If in examination they ask, define the magnetization intensity means, in terms of the formula if I talk, it is actually, I can define the same material. If I take here the magnetization, this material due to the external magnetic field, therefore if I say this material at the length 12 and the pole strength of this is mm and this is our area of the material which we have placed inside a external magnetic field. So in this, this is our external magnetic field, this is the magnetization. Because of the magnetic field, external magnetic field, the material has magnetized due to the external magnetic field. And this is our area of the material and the length of the material is 2L if I say. So here you can define this. As I told you, the material consists of the large number of atoms. Each atom having the dipole moment. Yes or no? Therefore, here whole material means have to take the net magnetic moment of this material. Therefore, here it is represented by the magnetization intensity is represented by I, that is equal to the net magnetic dipole moment of this material to the per unit value. Okay, that means in terms of the mathematically if I talk, the magnetization intensity I can define it as the net magnetization or magnetic dipole moment of the material per unit value is for our magnetization intensity. Therefore, I can say the net magnetic moment per unit value which defines our magnetization intensity. Therefore, if I talk, this is the general formula for our magnetization intensity. On what factor it is depending? It is depending upon the nature of the material. What do you mean by the magnetization intensity? It tells us about how much extent the material is going to magnetize when we place it inside the external magnetic field. Therefore, in terms of mathematically if I talk, the magnetization intensity is nothing but the net magnetic moment per unit value which defines our magnetization intensity. So, in terms of what is the unit of this? The SI unit of the magnetization is ampere per meter. How is ampere per meter? Just I will say here. So here the net magnetic moment, that is, as I told you, if I talk about the magnetic dipole moment of this material is what? As I told you, the dipole moment is represented by the pole strength times the length of the material, which is 2L, divided by per unit value. The value is measured in terms of the area and the length of the material. Therefore, A times our, that is area times our 10 minutes. Pause. Okay, the magnetization intensity, as I told you, the SI unit of the magnetization intensity is ampere per meter. How it is ampere per meter? As I told you, the definition of the magnetization intensity is what? The net magnetic moment per unit value. That is what, as we have already studied, the magnetic dipole moment. How you are going to define the magnetic moment there? It is nothing but the pole strength times the magnetic length. That is what our material length is 12 and the pole strength are M. Therefore, times per unit value I am saying. Therefore, how we are going to measure the value? Area times our length of the material. Therefore, 2L. Therefore, here I is equal to M by A. Here 12, 12 they cancel. Here another definition it has arisen. That means you can define either the magnetization intensity as this, that is net magnetic moment per unit value, or else you can define in another way, that is what, the pole strength per unit value. That means the pole strength of the material per unit area of cross section of the material is A. Therefore, here the pole strength is represented by ampere meter. In the last class, just check out the last class. The unit of the pole strength was ampere meter and the area is meter square. Therefore, here meter get cancelled. Therefore, we left with, that is ampere per meter. That is what the SI unit of the magnetization intensity is ampere per meter. So this is what about the magnetization intensity. Okay? Magnetizing force, or you can call it as the magnetic intensity. It is represented by the term that is H, capital H. Okay? In the last class, we have seen the concept of the magnetization intensity and the representation of the magnetization intensity, unit of the magnetization intensity, and what do you mean by the magnetization intensity. That was the first important term in the magnetism. The second important terms in the magnetic properties are the magnetizing force or the magnetic intensity H. What do you mean by this? It is generally represented by the term capital H. Okay? So how are you going to define this magnetizing intensity? This is nothing but the degree to which the material to which force is nothing but the degree to which a magnetic field can magnetize. What do you mean by this magnetic field can magnetize? As I told you, identify, take the electromagnetic field B0. This is our B0, which is nothing but the electromagnetic field. In this field, if I place a magnetic material inside this, what happens to the material? The material gets magnetized. So now that means inside this it produces the magnetic field. Due to the magnetic field, the material has a magnetized. That means the magnetic property is acquired by this material due to the external magnetic field which is present in the space, the fiber. Therefore, in case of this, generally the magnetizing force generally talks about the strength of the material. That means what material? The magnetic material which I have placed. It is what? The strength of material. How much strength is acquired by this material is decided by the magnetizing force or as the magnetic intensity, because the more magnetic field lines pass through this, the more magnetization is occurring in this material. Therefore, mathematically, if I write this magnetizing force or magnetic intensity H as the B by mu, the ratio of the magnetic field of the material to the permanent permeability of the material. Okay? Or in another case, I can write the magnetizing force H is equal to B naught by mu naught. Here the naught which represents the external magnetic field to the magnetic permeability of the free space. This is the magnetizing force of the material. This is the magnetizing force of the free space. That is B naught by mu naught. This is the material magnetic field. This is the external magnetic field. This is the magnetic permeability of the material which I have placed. This is the external magnetic permeability of the free space. That is mu naught. What is the unit of this? As I told you here, the SI unit of this is again the same as of the magnetizing intensity. That is what? Ampere per meter. That means the magnetization intensity unit, that is ampere per meter, whereas the magnetizing force or magnetic intensity, it is also the same unit, that is ampere per meter. That means it talks about the strength of the material. How the strength is going to rise means how much the magnetic field lines it can pass through this. That is what the degree to which the magnetic field can magnetize this. The more magnetic field lines pass through this material, that much more the magnetizing of the material is going to occur. Okay, so this is the magnetizing force. Okay, the first term we have studied the magnetizing intensity, magnetization of intensity. The second is magnetizing force or magnetic intensity, and the third concept is the magnetic susceptibility. It is represented by Xi. Okay, like delta S and X. This is our Xi, or some says it is a chi, but I say it is a Xi, which represents our magnetic susceptibility. What do you mean by the magnetic susceptibility? The magnetic susceptibility means how much easily it can magnetize. Okay, how much easily it can magnetize when we place under the external magnetic field. Therefore, it is the property of the substance which shows or measures how easily a substance or material or a specimen, okay, how easily a substance can magnetize. Okay, that means this is our again the external magnetic field B naught. If I place the material inside this, how much easily this magnetic material is going to magnetize. That means the more magnetic susceptibility means the more magnetic field lines are passing from this material. That is what, in mathematically, if I draw the susceptibility, that is Xi, that is susceptibility of the material, I can write I by H. That means the ratio of the magnetization intensity to the magnetizing force. That means it is about the material. What I am talking about magnetic susceptibility is what? Our material susceptibility. It is the property of a substance which shows how easily a substance can magnetize. All the material are not going to easily magnetize there, but some material, that is whichever acquire the magnetic properties easily because of the unpaired electron present in the material, those material is going to become magnetized easily. Okay, therefore, how you can define the magnetic susceptibility is it is the ratio of the magnetization intensity to the magnetizing force of the material. That is, what is the intensity of magnetization, as I told you, the intensity of magnetization of the material to the H means the magnetizing force applied to the material, substance again. Okay, that is what the magnetic susceptibility. How can we define? It is the ratio of the intensity of magnetization of the material. That means this material as magnetized. Why it is magnetized? Because we have placed this material into the external magnetic field. Due to that, the material gets magnetized here. To the magnetizing force applied to the material. That means here the force we have applied. Okay, the more number of magnetic field lines pass through this, the material is going to magnetize more. Okay, therefore the ratio of I by H is what our magnetic susceptibility. Generally, how easily this magnetic material is going to magnetize is measured by this susceptibility. More magnetic susceptibility means the material is so magnetized. Okay, so what is the unit of this one? Yes, just we have learned what is I, that is magnetizing intensity. This is H is magnetizing force. The both are ampere per meter. This is also ampere per meter, which cancel out each other. Therefore, it is actually a unitless and a dimensionless quantity, that is magnetic susceptibility. Okay, on the basis of this magnetic susceptibility, some of the material is going to bifurcate, that is dia, para and that is what ferro. Okay, so this is what all about the magnetic susceptibility.